So this question is about the Haber process. So in the Haber process, remember, it's ammonia that is being produced, right, from nitrogen and hydrogen in the air. Right, so the forward reaction is exothermic, so it gives out heat energy. So the conditions used are 200 atmospheres of pressure, 450 degrees, and an ion catalyst. Right, so we know what the equation is. So we need to go and explain how we're going and we're working out this to go and give us the maximum yield of ammonia. Right, just to remind us, the equation is 3 lots of H2 plus N2. It's going to go and form 2 lots of NH3. Right, remember it's a reversible reaction, so it can go in both directions. So the first thing that we can talk about is the pressure. So a higher pressure goes and gives a high yield. We don't want to go and use too high pressure because it causes a risk of explosion. High pressure is costly to maintain, however. However, high pressure will go in favour of the forward reaction because we're going from 4 to 2 moles. Second thing that we can talk about is the use of an ion catalyst. So an ion catalyst is going to speed up the reaction. This means that we can do it at a lower temperature. So we go and we save energy. So that is going to go and increase the rate of reaction in both directions. We can talk about a high temperature being used because that means that the particles would have more kinetic energy, so would collide more. So a high yield would be acquired at a lower temperature. However, if you use a lower temperature, it takes too long. Finally, you can talk about all these things being compromise conditions. So we compromise at 200 atmospheres, we compromise on a temperature of 450 degrees, and the fact that any unreacted nitrogen and hydrogen are recycled back into the process so they are not wasted. Right, so that's just a few key things that we need to think about when answering questions on the Haber process.